So this exercise is related to the Doppler's effect and the pulse echo techniques. I have solved about 15 questions from this, so we'll start with 16. Okay. A spectator at a motor race records the frequency of a sound he hears as a racing car drives past on a straight part of a track. The graph shows how the frequency of a sound he hears vary with time. As you can see here, this is a graph of the frequency and the time. So a spectator is observing, like he's, say this is representing a track, and the car passes the spectator at time x, as shown on the graph. Means when the car is just passing the spectator, like say spectator is at this position, I'm also representing that position as x. So first, how we can identify, like the frequency is higher, then the frequency, when it is at x, that is the position, and then it move away. This is what happened. And you can see here how we can identify that this car is approaching a spectator because the frequency was higher, what he received. And then the frequency is lower. And this is a change between the two. Because why there's a difference? Because first the car was moving towards, and then the car is moving away. When the car is moving towards, he will receive a high frequency, what is actually produced. And when it is moving away, then he will receive the lower frequency, what is produced. The next is the question is explain the shape of the graph, and it's of 4 marks. So for what are the points? First thing, because the change in the frequency or the wavelength is caused by a Doppler effect. When you mention, and this happened because of a motion of a source or observer, but in this case, the source is a car that is producing a sound. So in this case, the motion of a source is causing a change in frequency, which we call a Doppler effect. And the second thing, before the time x, the car is moving towards the observer. That's why the frequency was higher. But after x, the car is moving away from the observer. That's why the frequency has decreased. And at position x, when the car just passes the nearby a person, that time the frequency which is produced by the car is actually same as the frequency heard or recorded by the observer, the spectator. Because when object and source are just next to each other and they're producing a sound, or a source is producing a wave, that is the frequency what is actually produced by the source. Others are not the actual frequency produced, that are the relative frequency due to a motion of the source and observer. So how to score the marks for this 4 mark question? First thing, the frequency changes due to the frequency. I'm writing in short frequency, but in exam you should write complete. So the frequency changes due to motion of source, which is known as the Doppler's effect. Then the frequency, the apparent change in frequency due to a motion of a source, we call Doppler effect. And before x, the car is moving towards the spectator because the frequency is higher. and after point X, car is moving away. So the frequency is shorter, and when the frequency increase, the wavelength will decrease, but the speed will remain constant. And the last point at X, the frequency of the wave produced by the car is same heard by the or recorded by the observer. So these are the points you should mention related to a Doppler effect. The next question 17. Figure shows an ultrasound detector is there. So the estimator, this is estimator is there, is held against one wall and it emits the pulses of ultrasound and detecting them after the reflection of the opposite wall. Explain why ultrasound must be emitted in pulses. Like why he should use a pulse, why not a continuous sound? So because so that it can be able to distinguish between the reflected and the emitted pulse. Or so one pulse returned before the next is emitted. So main reason is to distinguish between wave produced and reflected. Otherwise, if we use a continuous wave, we won't be able to recognize which wave is the produced one and which one is a reflected one. The shortest distance the estimator can measure is 40 centimeter. Calculate the longest pulse duration which will allow this distance to be measured. The speed of the ultrasound is 330 meter per second. So we want to calculate the pulse duration. So the distance here, like this is a source, reflecting surface, it will bounce back and return. And the distance, a shortest distance, the estimator can measure is 40 centimeters. So this is 40 centimeter or 0.4 meter. And the sound, ultrasound is produced, which is 330. So we have the formula speed is 2d over t. Like speed is twice the distance over time. If we need the time, because the pulse duration means time, like how much time it will take. So total time, so it will be 2d over v. So 2 multiplied by 0.4 divided by 330. So it will be 0.0024 seconds. That's the time. That's a pulse duration. Like duration of a pulse means like how much time it will take to strike the surface, a reflecting surface, and return back from the time when it emits, like time interval from emission till the detection. Then we have when estimator is pointed at a slope, the photograph is in the photograph it is unable to measure the distance. Why? Why in this case it won't work? Because see, when this estimator is send the ultrasound, it will undergo a reflection. So when it will reflect towards the bottom. So the walls which are inclined or angled, this won't work. It was only working for the previous question. Why? Because the wall was vertical and it was having a like no inclination is there for a wall. So when estimator is pointed towards the wall, it hit the wall and bounced back. So using a pulse duration, we can just estimate what is the exact distance. But here what happened is when it is sent, it won't reflect back to the estimator. It will reflect back. It will reflect back to the estimator. It will reflect to the bottom of the floor. So that's why it won't detect. So when estimator is pointed at a slope wall, it's unable to measure the distance. Why? is unable to measure a distance? The simple answer that because the wave which is reflected is towards the floor instead of bounce back, as it is inclined or the wall is making certain angle. Is it clear about the pulse echo? Any question or a doubt related to this topic?